So let's look at the following example. I want you to find the relative extrema of the function x squared minus 4 to the 2/3 power. So I need my derivative. You gotta do the chain rule here. Bring the power down, reduce the power by 1, so it'll be negative 1/3. And you've got to multiply by the derivative of the inside, the derivative of x squared minus 4, so that'll be 2x. So I'm going to simplify this a little bit. F prime of x will be 4x over 3, and I'm going to move that term with a negative power to the denominator. So now we need to find our critical numbers. So here, where is my function undefined? Well, it's when the denominator is 0. So I'm going to have to set x squared minus 4 to the 1/3 power equals 0. X squared minus 4 equals 0, so I get x equals plus or minus 2. And then I also need to know where is my derivative 0. So I need to set the numerator equal to 0. I get x equals 0. So I get these 3 critical numbers. So I'm going to draw my number line now. And on it, I'm going to put -2, 0, and 2. And here I've got 4 intervals. So I need to pick test points in each one. So I'll pick -3. I'll pick -1, 1, and 3. And plug them into my derivative. And again, you just need to know the sign. If I plug in -3, -3 squared will be 9 minus 4. So here I'm getting a negative over a positive, so it will be negative. Plug in -1. Three times -1 squared would be 1 minus 4. So here I have a negative in the top, and I'm going to have a negative in the bottom. So overall it'll be positive. And repeat this for plugging in 1. So if you plug in 1, it'll be a positive over a negative, so negative. And plug in 3. It'll be positive over positive, so it's positive. So let's classify these now. Let's think about what our function's doing. Our function is decreasing and then increasing. So that would be a relative minimum. Here it's increasing and then it goes decreasing. So this would be a relative maximum. And then here my function goes from decreasing to increasing, so it's a relative minimum. And so now I've got 2 minimums. My x values are -2 and 2. If we go back to our original function, we can actually get a point here. So If I plug in 2 or negative 2, my function would be 0. So we're going to have a relative minimum at the point negative 2, 0 and at the point 2, 0. And when x was 0, we had a maximum, a relative maximum. When x is 0, then you're taking the cube root of 16. So there are my minimums, my relative minimums, and there are my relative maximums using the first derivative test.